In this lesson, we are going to be using the mean to calculate new data sets, or means. We can interpret the data using the mean, and we can state how an outlier may affect the mean. So, to review, remember that the mean is the average. This is found by adding together all of the data, so that would be the sum of the data, and when we add the data together, we divide by the total number of pieces of data that we added together. And when we divide those, we get the mean, which is called the average. So here's an example. When we are finding the mean of this data set, we have 7, 4, 9, 12, and 10. We add those together to get 42, and then we divide 42 by 5, and our mean, or our average, is 8.4. So, why is the mean not always the best measurement of our data? Well, let's take a look at two situations, and let's pretend that these are your test scores. In situation A, you scored an 84, an 82, an 89, and a 79. So basically, you scored B's on 3 of your tests, and just below a B, a high C on your other test. So when we add those scores together, divide by 4, we have 334 over 4, and that gives us a mean, or an average, of 83.5%, which is a B, and that seems fair. What happens though if you're in situation B? You still scored an 84, an 82, and an 89, but one day either you weren't feeling well, didn't get enough rest, or didn't prepare, and you scored a 45% on the test. So here you've worked hard, earning 3 B's, and now you blew a test. So let's add those together, getting 300, and divide by 4. Your mean, or your average, is a C. Doesn't seem like that's quite fair, but that's what happens when we use the mean. The 45 is called an outlier. It's a piece of data that doesn't quite fit the situation. And what happens with an outlier is it affects the mean. You can see that with your 84, 82, and 89, which were all B's on your tests, is that when you have one outlier, which is one poor score, that brings your grade down to a 75%, or a C. So, the mean isn't always the best situation for your data, but it's generally one that we use. So, we have another way that we can use mean. When we do mean, remember that it's the sum of the data, and that sum is divided by the number of data pieces that we have. We could also use that in reverse. There may be a time when we want to know, and we give you the mean, and we tell you how many pieces of data there were. There are times when I'd really like to know what the sum of my data was to begin with. Well, the way that we can do that is actually do in reverse. We can then take the mean times the total number of pieces of data that we began with, and that would equal what the sum of our data was. Let's take a look at an example where this might apply. So, on the last 4 tests, you scored a 90%, 88%, 82%, and a 96%. Your parents told you that you can't go on the trip unless you have an average of a 90%. What would you need to get on your next test to get that average? Well, the first thing that we need to do is we need to figure out how many tests that we would have if you were able to take one more. So, if you had a 90% average, let's see if the original scores on your 4 tests would be 90%. So we're going to take 90 and we're going to add the 88 and the 82 and the 96 together and see if that is an average of a 90%. So when I add those together, I get a score of, or a sum of 356. If I divide that by 4, that gives me an average of 89%. I'm not quite there. So what can I do? Well, what if I take one more test? What would I need to get on that test to bring my average up? If I need an average of 90%, I want to actually multiply 90 by my 5 tests that I would have and realize that that would be a total of 450 points. If I take that 450 and I subtract 356 total points that I have so far from my first 4 tests, I would see that on the 5th test, I would need to score a 94%. This is what I would need to get on my next test. Let me explain that one more time. What I would do is I would take the first 4 tests that I've already done and add them together to get my total amount of 356. I was just checking to see if that was enough to give me a 90%, and it wasn't. So what I would do then is to multiply 90%, the average I want, by the 5 tests that I will have and realize that I need a total points of 450. If I take the points I have now and subtract that from 450, that tells me that on the next test I need to earn a 94%. Let's try another example that's similar to this. To win a golf tournament, your team of 4 needs to have the scored average to 80 or lower. The first 3 players came in with an average of 81. What does the 4th score need to be to reach the desired average? Remembering that in golf, the lower the score, the better. Okay, your team of 4 needs to have scored 80 or lower. The first 3 players came in with an average of 81. That means we added their 3 scores together and divided by 3 to get 81. So I want to work in reverse. I want to take the 81 and I want to multiply that by 3 to get the total points that those 3 players have earned, which is 243. Now we want to see what happens if I have 4 players that we want to have an average of 80 or lower. So I'm going to take what I want my average to be, which is an 80, and I'm going to multiply it by 4 to show that I need 320 total points for the 4 golfers. Now if I subtract those 2, I would find out what the 4th golfer needs to score in order to bring the average down to an 80%. When I subtract, that golfer would need to earn a score of 71. So again, I took the average and multiplied it by how many people there were to get back to my total points. Again with my 80, and I subtract the 2 to figure out what that golfer would need to have. Let's take a look at another example. 20 students were asked how many text messages they send a day. The mean number of text messages is 140. However, one student said They send 400 text messages a day. Wow, that's a lot. This particular student's data is an outlier. Let's check to be sure. What happens if we would remove the student from the data set? Would the mean get higher or lower? Well, let's see. If 20 students were asked how many text messages they send and the mean was 140, I want to know how many total text messages those 20 students sent. So remember, to find the mean, we divided by 20. I want to multiply by 20 now to find out what the total text messages were. That would be 2,800 text messages from the 20 students. Well, let's take out that 400 text messages from the one student. And that leaves us with a total of 2,400 text messages. And now, instead of 20 students, we are going to worry about 19 students after we took that student out of the mix. So let's find our new mean. So we'll take the new amount of text messages that we have, 2,400, and we're going to divide it by 19 this time and see if our mean went up or down. So when we divide, we get an answer of 126.3 text messages. Our mean is lower. What that tells me is if I have found the mean and I remove an outlier that is high, that's going to bring my average down. Likewise, if I had an outlier that was very low and I removed it, that would bring the scores up. For example, on the test that we talked about originally, if I were to remove the low score of that student, my test average would go way up, back up to a B as a matter of fact. So, in review, remember the mean is the sum of the data divided by how many pieces of data there are. We can also take the mean and we can multiply it by how many pieces of data we had, and that would give us our original sum, and we can use that to apply the mean to other situations. We also have learned that there can be outliers which can affect the mean. Please remember to complete the reflection.